Greetings. Today, let's move into lesson 8.7. We're going to learn another method for solving our quadratic equations. And I'm going to state it again like I did in lesson 8.6. This is a method that will work sometimes, but not for all quadratic functions. So our method today is using the square root method. So the first thing I would like you to do is probably circle when our b value is equal to 0. So in other words, if we do not have the bx term, because b times x, 0 times x would be 0, the x term would be wiped out. So if there's no x term in our quadratic, we can use this method. So we're going to set the ax squared equal to the c term, to the constant. We're going to divide both sides by the a term, and then we can take the square root of both sides. And the reason that our goal is going to be to take the square root is because we'll have an x squared term, and when we take the square root of x squared, we get x, which is what we're solving for. Let's be reminded though also that when we do find the square root of something, we have both a positive and a negative square root. We talked about that back in chapter 6. Okay, let's go to practicing. X squared equals 25 is our quadratic function. Notice it has the ax squared term, it has the c term, it does not have the bx term, it doesn't have any just x's. So we can look and see, do we have the ax squared set equal to c? Check, yep, that's already done for us. Divide both sides by a. Well, our a is 1. Not necessarily to do that because we're still going to end up with the same result. So we can go directly to our third bullet point there, which says take the square root of both sides. The square root of x squared is our x. Equals, remember we have a positive square root, we have a negative square root, and 25 is a perfect square. The square root of 25, 5. So we have our solutions for our quadratic function. We have 2 solutions, 2 zeros, 2 locations where our parabola would cross the x-axis at both positive 5 and at negative 5. Okay, number 2. We have an ax squared term on the left side. We have the c term on the right side. We don't have an x term. This is a good one for our square root method. So we already have it set equal to the c. So the first thing we will do is we will divide both sides by the 5. And again, remember these notes are going to be useful for the final. Make them as complete as possible so they're going to be helpful to you. You do not get to ask questions during the final. Dividing both sides by 5. On the left side, we end up with x squared. On the right side, 245 divided by 5 just so happens to be 49. Good news, because 49 is a perfect square, so that when we take the square root now of both sides, so remember, whatever we do to one side of the equation, doesn't care what it is. Whatever we do to one side, we do to the other. Square root of x squared is x. We have a positive square root. We have a negative square root. The square root of 49 is 7. So our solutions are a positive and a negative 7. Again, we have a parabola crossing the x-axis in 2 locations. It has 2 zeros. We just found them. They are 7 and negative 7. Okay, moving on to number 3. Again, we can see there is not a x term. The bx is not there. B must be 0. So this is a good square root method one. But do we have the ax squared term set equal to the c term? No. Does it matter which side either of them is on? No. So let's just, so that we can deal with working with a positive, Let's move the 64x squared over to the right side. We'll let the c value be on the left side, and our ax squared value will be on the right side. Well, that's not a big deal because you remember inequality means one side is really the same as the other, so in reality they could just trade places. And so let's have them do that. And then we have to divide by a because a is not 1. We're going to end up with x squared equal to, well, now you're kind of probably thinking, 9 64ths, I can't take 64 into 9. And so what we're going to do is we're just going to leave it as a fraction, okay? So don't worry about renaming that at the moment. Okay, now we're going to take the square root of x squared. If we take the square root of x squared, we also have to take the square root of that fraction. Let's remember that when we do that, we can actually give each of them their own radical sign. So we can take the square root of 9 over the square root of 64. We are going to have x by itself now because the square root of x squared is x. Positive or negative, this is what you're going to forget, is that there's a positive and a negative square root. Square root of 9 is 3. Square root of 64, 8. There are our two solutions, a positive and a negative 3/8. Our zeros are locations where it will cross the x-axis. This is one of those that if you gave your answer like this, or possibly it could be shown in an answer bank as a decimal, because this is a nice decimal, it is 0.375. But more likely, they'll leave it in its fraction form. That's probably how you would see it in an answer bank. Okay. Number 4. Again, there's not just an x term of bx. Our b must be 0. So we need to get our x squared set equal to a c to a constant. Well, we have constants on both sides, so we have to get that 3 moved out of there. So we have 25x squared equal to 121. Our a value is not just 1, so we have to divide both sides by our a value. So our x squared is on the left side, positive or negative. And 25 cannot be taken a nice integer number of times out of 121, so we will leave it 121 over 25. All is well because, what's cool about both of those, the numerator and the denominator, they are both perfect squares. Oh, I take that back. Would you just erase that plus or minus? We haven't even done the square root yet. Silly me. Now we're going to introduce the radical sign. We're going to take the square root of x squared. We are going to take the square root of 121 over the square root of 25. Everything gets a radical sign. Now we want our positive or negative, because when we take the square root, we get a positive and a negative. Square root of 121 is 11. Square root of 25 is 5. This is very likely how you would see it in an answer bank, but we're going to give it 2 other ways we might possibly see this. Because it's also kind of nice to know where is this parabola crossing the x-axis at. So a better picture would be a positive or negative. Write this as a mixed number, 2 1/5. That gives us a better picture of those zeros. But then since 1/5 has a nice decimal name, we could also write it as its decimal name, or it could show up as its decimal name as 2 and 2/10. So again, we must know all of the different ways that we can really name something, just in case it isn't provided in an answer bank the way in the form that we got it. Okay, well, what's going on here on this side is every single time we had perfect squares to deal with. What if we don't? Does that mean that we can't use this method? No, let's go to the back side. As long as b is 0, you can still use this method. But sometimes the number you are going to find the square root of is not a perfect square. Which is really not a big deal. We just have to work a little harder is all. And when we have, so we can still use the directions we have in the front. When b is 0, get the ax squared term set equal to the c term. Divide both sides by the a value. Then take the square root of both sides. This time, when we take the square root of both sides, though, because we are not taking the square root of perfect square, we have to give our answer in 2 ways. We have to learn how to do this both ways. The first way is going to be important for you to know for geometry next year. So the first way is leave it in what we call simplified radical form. In other words, there will still be a radical sign, a square root symbol in our answer, but we will have simplified it. And then when they call this, if they say to you they want the exact answer, the simplified radical form is what we call our exact answer. We have done no rounding. We have not approximated anything. And then the other option, the other way to give our answer is we're going to round, because when you take the square root of a non-perfect square, there is a name for that type of number. The square root of a non-perfect square is like pi. It is called an irrational number. If you would put in the square root, take the square root of 5 right now on your calculators, you would see that you would get 2 point, a bunch of stuff behind the decimal point. Just like pi, there would be no repeating pattern. It would never terminate. It goes on forever and ever and ever. So we have to round it if we want an answer that is not the exact simplified form. If we want a better idea of where we're at on the number line, then we have to round it. So we're going to round to the nearest hundredth. And we call that our approximate answer, so that we have a visual, a picture, a way to check to see if we graphed our parabola correctly, or to maybe check to see if we have the graph, did we get the right zeros for the function. Okay, so we're going to just do like we were doing on the front. Number 5, we have our ax squared term already set equal to our c term, so we can go to the step that says, do you need to divide by a? Yes, we do, because it's not 1. So now we are going to have x squared set equal to 81 divided by 3, which is 27. Well, we just ruined our perfect square, 81. We just made it into a non-perfect square, but we had to, because we need to be able to take the square root of x squared to get our x. And so we're going to have to take the square root of 27, not being a perfect square, positive or negative still, square root of 27. Okay, we are working on what we call the exact. I want you over here in the margin to put exact. This is what we're going to work on right here. And you need to listen carefully, because this is going to be a big deal. I said in geometry next year that you can do this. 27 itself is not a perfect square. So what we're going to look for are there any perfect squares under 27, that can divide into 27. In other words, can we rename the square root of 27 as the square root of a perfect square times the square root of the factor for that number that you're taking the square root of that perfect square. So 4 doesn't go into 27. I didn't start with 1 because 1 isn't going to get us anywhere. 4 doesn't go into 27. Next perfect square is 9. Ooh, 9 goes into 27. So I can rename this as the square root of 9 times the square root of it, whatever times 9 is 27. Well, that's 3. So I can rename it like that. Purpose for that is we're simplifying it. Okay? So x equals a positive or negative, and we're using the equal sign because remember we're doing the exact right here. Square root of 9 is 3. We get rid of the radical sign because we can take the square root of 9. Square root of 3. Now we ask ourselves again, now we have another non-perfect square. Is there anything that is a perfect square that divides into 3? The only one that can go into 3 is 3 and is 3 and 1. And 1 being a perfect square, that one's not going to get us anywhere, so we are just going to leave it the square root of 3. We can ditch the multiplication symbol. This is how we would see our answer written in simplified radical form. X is equal to a positive and a negative, 3 square roots of 3. Another way you might hear that said, 3 radical 3. Really what it is 3 times the square root of 3. Or in other words, if we put into our calculators the square root of 27 and found out what that displays, and then we put into our calculators 3 times the square root of 3 and see what that is equal to, those two values should look exactly alike. This is just another name for the square root of 27, but it has been simplified and left in radical form, in other words, what we call exact. Now let's deal with the approximate. We'll call approximate APPROX, okay? Let's deal with the approximate. Now we are actually going to approximately equal to, now we are actually going to put into our calculators, we have a positive and a negative, we're actually going to put in our square root of 27, we are going to find it. So the square root of 27, we're rounding to the nearest hundredth. When you put the square root of 27 into your calculator, it should display 5.19, so right now that's 5 and 19 hundredths, but that 6 behind it has to decide if the 19 hundredths should be rounded up to 20 hundredths. That 6 is going to round it up, so we are going to say 5 and 20 hundredths, and yes, that 0 is important because we're showing that we rounded to 20 hundredths, not to 2/10. Okay? Now, we're not going to circle that. I just want you always to circle your exact answer and then put the approximate underneath it. We're going to check both tomorrow, but I don't want to circle it because I don't want you to think there are 4 solutions. There are still only 2 solutions. These are just 2 different ways to represent those 2 solutions. And now we have a better idea with this approximate one, a positive or negative 5 and 20 hundredths. Now we can say, oh, now we know about where it should cross the x-axis, at positive 5 and 20 hundredths, at negative 5 and 20 hundredths. It gives us a better picture. Okay, let's move on to number 6. We don't have ax squared set equal to c, so we will have to move one or the other. Let's move the constant over to the other side. Doesn't matter which side we do it. 0 take away 64, we have a negative 64. Now we will divide both sides by our a value because it isn't just 1. So we have both sides being divided by 2. We have x squared alone now. We have a negative divided by a positive is a negative, and 64 divided by 2 is 32. So we have a negative 32. Next step, take the square root of x squared, take the square root of negative 32. Well, the square root of x squared is x, and the square root of negative 32. Oh, wait a minute. Can't take the square root of a negative number. Square root means a number times itself that will give you negative 32. Well, a positive number times itself would be a positive times a positive, that's a positive. And a negative number times itself would be a negative times a negative, that's a positive. There is no way to get the square root of a negative number. Your calculator would say error or something to that effect. So we are going to say this has no, and this is what, remember we said, they can have imaginary solutions, but we can say this one has no real solution. No real solution. And maybe you want to make that little extra note in your notes that says, can't find square root, we'll just abbreviate like that, of a negative number. Not possible. So this doesn't have any real solutions. We call them imaginary solutions, or in other words, we still have a parabola here, but we have a parabola with no zeros. It's one of those parabolas that will not touch or cross the x-axis, but it is still a parabola. Okay, no real solution. Number 7, our last one. Well, we need to get the x squared term set equal to the c term. You know what, I always like to deal with positives as much as possible, so I'm thinking I'm going to move the 5x squared. No matter what I do, I have to make 2 moves. So I'm going to move the 5x squared to both sides, or add it to the other side to get rid of it on the left side. So now I have 125 equal to 25 plus 5x squared. Need to make another move. We got a constant over there with that 5x squared, so we'll get rid of that constant, 25. And now we will have 100 equal to 5x squared. Life seems pretty good right now because you know what, 100 is a perfect square. Oh, it doesn't matter. Our a isn't 1. We have to divide both sides by that a value of 5. And now we actually have to wreck things because 100 divided by 5 becomes 20, which is not a perfect square. But so it is. Now we will take the square root of 20. We will take the square root of x squared. Or if you like it better this way, have them trade sides. Well, the square root of x squared is x equals, we're going to do the exact first. We're dealing with the exact first. Remember, that is simplified radical form. So positive or negative. 20 is not a perfect square. But are there any perfect squares that go into 20? So let's start at 4. Oh, 4 does go in. So the square root of 4 times the square root of, what times 4 is 20? 5. So we can rename the square root of 20 as the square root of 4 times the square root of 5. X is equal to a positive or a negative. We can take the square root of 4. It is 2, no more radical sign. 5, square root of 5. 5 is not a perfect square. Doesn't have any perfect squares that can go into it, so we can rename it. No, so we're going to have to just leave it the square root of 5. Simplified radical form. We have 2 solutions. The positive 2 square roots of 5, the negative 2 square roots of 5, and now let's do our approximate. In other words, let's just rename our solutions so that we can have a better picture of where we're at on the number line. So x is approximately equal to a positive and a negative. Still 2. Remember, there's 2 of them. And now you'll put the square root of 20 into your calculator. It should read 4 4/47 with a 2 behind it in the thousands place. Is 2 big enough to round that up to 48/100? No. So we have to leave it, we'll leave it 47/100. So now we have a better picture of what the square root of 20 is. Where are those zeros actually at? And again, we're not going to circle it because then it might look like we think we're going to be misled thinking that there's 4 solutions. There are just 2 of them. We're giving the exact name of them. We're simplified radical form. We're giving the approximate rounded to the nearest 100. Okay, this is what you'll be doing in your homework today. Good luck, and I will see you again tomorrow.